we solved equations, right? We learned various techniques for solving different types of equations, with the end goal of finding having the skill or the task of solving multi-step equations. So I can give you multiple terms on both sides of the equation, multiple variables or variable terms on both sides of the equation, and we can get to the end all of being all my variable terms on one side, all my constants on the other side, and then end up dividing by my coefficients to get my solution, right? That's what all of Chapter 2 was really based on, being able to do that. That provided us an answer that showed that this is where the left side of the equation is equal to the right side. At this only x value, that's what makes this equation true. Every other number makes them unequal. Every other number that you would plug in would make the left side different than the right-hand side, right? So we got equality and we got unequal, right? Okay. When we talk about unequal, okay, the grammatical way of saying it is inequality. Okay? Inequality. But if I just say, let's say, Lindsay and Cameron have, Lindsay, is older, or let's say Lindsay and Cameron have different birthdays. So that means they are not the same age, right? So I can't say Lindsay equals Cameron. Now listen, it does.
Not that they're different birthdays. If they have one birthday. So
you're saying age is only predicated off the year.
Yeah.
Your age is how old you are from the time you were born to now.
Well, yeah.
Right? So if they have different, so let's say that, if Lindsay's been alive at a different amount of time than what Cameron's been alive, okay, we would not say they're equal, right? Mm-hmm. We would say they are unequal, okay? But if I just say that Lindsay's age does not equal Cameron's age, I don't have a comparison other than knowing that they're not equal, okay? But don't I have the ability, if I know that they're not equal, don't I have the ability of saying, okay, maybe Lindsay is older than Cameron, right? So now I know how they're unequal. They're unequal, and now Lindsay's is greater than Cameron's, right? Can I reverse that and say Cameron is less than Lindsay? Does that make sense to everybody? Okay. So inequalities are a mathematical statement that allow us to state two expressions to be unequal. I don't think that's enough because it tells us how they should be unequal. Okay? If I look at that up there, so my expression 1, expression 2, those are going to be variable expressions. They're going to have plus constants, minus constants, that kind of stuff. So it might be like 2x plus 3 on the left and x plus 10 on the right. Okay? But if I read that expression 1, how do I read this symbol right here? Expression 1 is less than. Okay? So when we talk about inequalities, that's what we're referring to. We're referring back to our less than sign. So we would say expression 1 is less than expression 2. Okay? What would I call this one? Greater than. Okay? Now, when I do this, this is important for you to understand as well. We need to understand that you can read those two different ways. And I said that with Lindsay and Cameron's kind of example. Lindsay was older than Cameron, right? Lindsay's age is greater than Cameron. That means Cameron is younger than Lindsay. Cameron is less than Lindsay. Does that make sense? So when I look at expression 1 as less than expression 2 in that first line, can I also read that as expression 2 is greater than expression 1? So inequalities are things that you can read left and right, okay, and gain the same information. However, you got to understand that when this was an equality, you know, expression 1 equal expression 2, it meant the same thing both ways, right? When it's greater than or less than, it means something different on how I compare these. Here, expression 2 is greater than 1. Okay, does that make sense to everybody? Okay. Now there are situations, what would you call these down here?
Less than or equal to.
Okay, so expression 1 is less than or equal to. Expression 2.
More than.
Oh. That last one is greater than, right? Greater than or equal to.
The line.
Okay, so the symbol, so that little line underneath there, okay, is the equality part. Okay, so you were probably in elementary and they talked about, or maybe middle school, they talked about that. The alligator eats the bigger one, right? You guys hear that phrase before? Okay, so the inequality sign looks like the mouth or something, and it's going to eat the bigger number. That's fine if you want to remember it that way. Okay, I like to think about that inequality symbol as an arrow, and the arrow always points to the smallest number. Okay, which is really the same thing, same argument as the alligator eats the biggest number. Okay. Okay, that works. Okay, I like that. Yes, now that would work only if you're working left to right, correct? Okay. So he's saying if I read it left to right, I read that first one, expression 1 is less than expression 2. He tries to make that inequality sign with his thumb and his pointer finger, and when he does that, it makes an L in his fingers, right? So L means less than. I like that. That works. Now, we talked how we can reverse these, okay, if we need to. But the idea here, guys, is that these are going to tell us how to compare numbers on a number line. Okay? Numbers on a number line. And when we get through some of these down here towards the end of today, if I have two numbers on a number line, okay, I'm not even going to tell you what these numbers are. Here, let's say that's my number line. And I've got this number here that's orange, and let's take a number there and make it black. I'm not telling you what those numbers are. Which one's less than the other one? The orange one's less than the black one, right? Does that make sense? Anything further to the left on the number line is always, well, it might not be negative. It might be, that orange one might be 10, and the black one might be 100, right? But I know that the orange one is below or smaller than the black one, okay? That's why I need you to understand we're comparing things. So we would say that the orange one is less than the black one. Does that make sense? Or the black one is greater than the orange one, okay? That needs to be something that we pay attention to and understand when we start comparing some inequalities here in a little bit, okay? If you remember back to chapter 1, the first thing we did with equations is that we took a verbal statement and rewrote it into algebra. So that's what these are doing. Okay, now, for the most part, guys, this is exactly what we did in 210 when we just read the statement and said, okay, when it says all numbers x, it tells me my variable, so I write down x. Okay, are less than. Okay, so just kind of break this up as we move left to right here. Start this back up. My features kind of stopped working. All right, so as I move left to right, all numbers x. So I write down x. Okay? That are less than. That are, kind of working back to what we did in chapter 1. Isn't are kind of a version of is? Yeah. Is and are, right? That's what we learned in grammar. So, yeah, so that gave me my equality back in chapter 1, right? Well, now it gives me my less than sign. So I say less than, okay? And I keep going. It says or equal. So that makes me put the line underneath there, right? And now I keep going. The last thing I say is -7. So that's just taking left to right, taking those parts out, and writing down algebraically what those parts mean. So if I'm looking at numbers that are, what we're saying here, numbers that are less than -7. So if we go back up to this picture right here, we're saying that maybe that's -7. We're looking then for all the numbers that are left of -7. Does that make sense? What numbers are left of negative? What's the first number you think of when you go left of -7? -8. Okay? When I say x is less than -7, is -8 the first number that is left of -7? is -7.5 before then?
Well, if we're doing half.
Okay, so that's the question. So when I say number, I should be saying real number. Okay? Because numbers that are left of -7, -7.1, -7.01, -7.00000000001. Okay? Those are numbers to the left of -7. Does that make sense? When we write an inequality like this, guys, and this is what becomes maybe the biggest concern beyond this class when we start using these inequalities, is that we think whole numbers or we think integers. Okay? What we should be thinking is all the numbers on the number line. Okay? When I say x is less than -7, I'm not saying, well, the first number is -8. I'm saying the first number is -7, a decimal point, an infinite number of zeros, and then a 1 after it. Does that make sense? Okay. When we look at this one down here, this was a little bit different. Okay. I'm going to read it left to right again. It says 6 less than a number k. Okay. That phrase right there, less than. If you remember back to chapter 1, we said that less than, if you brought out your chapter 1 notes, you can see that somewhere in that we said, when we saw the word less than, it actually makes us flip the way we read it. Okay? And basically what we've been doing here is just writing down what we saw in words and transfer that into algebra, right? And just kept going left to right with everything. But when I see less than, okay, I'm not going to write 6 first and then minus k. Less than actually means you go k, then minus the 6. Does that make sense? And that's because subtraction is not commutative. Okay, so I can't just say 6 minus k. 6 minus k would be k less than 6. Less than is one of the few English phrases that actually tell us to flip what we're going to write down as we read it left to right. Okay. So the next part says is greater than. So greater than, which way should?
Taking towards them. Well.
Okay, so I'll put greater than 13. What I need, right? So which way should it? If it's an arrow, it should be pointing towards the 13, right? Is that what we're trying to say?
Yeah.
So this says k minus 6 is greater than 13. The arrow here. You know, everybody see that if I make that an arrow? Arrow is pointing to the smaller number. Okay. Go through the next one. All real numbers p greater than or equal to 1.5. Is that pretty easy? Do the next one on your own.
I don't know how to do that.
Why not?
Because it says and I'm not and.
Well, it says the sum. What's sum mean? Okay? So when you add, you need two things, right? The and is linking those two things. So T and 7 is less than.
The arrow pointing at them.
Yep. And then -3. All right. We'll pick up with this tomorrow. I'll start talking about the solutions to inequalities. When we solved an equation, there were 3 solutions that could happen. And we spent 95% of our time on the one type of solution. And that's when you get one answer back. When I solve an equation, I get one answer back. If you remember, sometimes we got equations that were gave you 0 equals 0 or 5 equals 5. And those were true statements. We had an infinite number of solutions. There were some that we had no solutions, where it gave us 5 equals 10 or something like that. With inequalities, you have an infinite number of solutions. So if I wanted to write down the infinite number of solutions, would I be able to do that? If I asked you to count something an infinite amount of times, can you do that?
No.
No, you would die doing that, right?
Yep.
And then the next person that picked up after you would die doing that. And then the entire population of the world picked up after you and tried to write the infinite number of solutions would die doing that, and we would never get those solutions written down because there's an infinite number of them. So we still want to talk about them. We still need to be able to express them and write them down. So mathematically developed a way of doing that. Tomorrow we'll get into that procedure. Okay. No homework this evening.